thank you for having me. I'm really proud to be here, to have my family here with me. I hope you enjoy my talk. So, stop looking at the code is something that used to be quite a bold statement, I think. And I would like to talk about our approach to developing with AI. So, I've been working at StrongDM. We've been recently acquired by Delinea, so I'm from Delinea now. And today we will go over our approach, then we will talk about the Agentic loops, then we will put the loops together, orchestrate their work, and finish up with some observations for later. So, why should you care about our approach to AI? We've actually had quite a few successes with developing without looking at the code. We've developed a driver for a Google Spanner database in 1 week, non-interactively, which previously took us 2 months. Then we became a little bit more ambitious and built a policy-based access control driver for MS SQL, which means that we can pick and choose what kind of statements we pass through it, and we have policies control over it. And it took us 2 weeks. Previously it was 4 months with 2 engineers. And besides that, it built a compiler for a programming language at my university in 1 prompt, which last year took a lot of prompting with DeepSeek. And in general, it one-shots every academic assignment I get at my university, at Wrocław University of Technology. So, now it's quite powerful. So, let's talk about our approach. So the initial vibes are quite clear. If you didn't write it, there is no way you can test it. And when you don't know how it works, you are not able to document it yourself. That's an obstacle. We found that it's best not to mix human and agent communications, and that the agent thrives best when you let it own the entire repo, make it all the abstractions unnecessary that it likes, adjust its taste, don't fight against it, and have them do it their way. Because we found that agents write to agents better than to humans. We also found recently, which is like last Christmas, that given appropriate constraints, when you hold it hand and don't allow it to stray off the path too much, we found that the modern agents compound correctness over error recently. So when you let it run for longer, let it consume more and more tokens, you end up writing Shakespeare, as with the mind here. So that's the approach. But there are still some hard parts that the human is required for. So the agent can't really have taste and can't tell a good idea from a bad one. It can't even tell a bug from a feature because it all depends on the context of what you're building. So the very important question still is, what do you want to build? You can outsource the doing, but you can't outsource the ideation to the agent. As the human business context in which your software exists is all that matters when you're building software. And we found that marketing and business-client relationships are not solved by AI still. So, our approach is to keep yourself out of the loop containing bulk work. You don't want to be doing the manual work. You should be there at the start to pick out the direction, because the agents don't know what you want. But you don't want to be writing every parser, every single part that is repetitive. The agent is unstoppable at do, but it is very much hopeless at what. So I invite you to the world of non-interactive development. And if you're interested in more, you can scan this QR code to see the page this talk is based on. So what you shouldn't be doing is copy and paste messages between agents. That should be out of your reach. You don't want to be answering the agents clarifying questions mid-build, because that requires your interaction and babysitting it. You should answer all the questions up front. You don't want to be reading the code to decide if it's ready, because the code is being written at such a speed that it becomes a bottleneck if you have to review all of it manually. And for research, for the ideation part, you don't want to be searching the internet yourself. You could have an agent gather and index the data. And in general, one of the mantras is, if you can read the tokens, the model can act upon the tokens. You don't need to be doing it yourself. So this is like an example. I had been talking with Claude, and he asked me if he'd like to do something, and I'm like, yes, always do it. Just do it yourself. So that was our approach, and let's talk agents now. Agent is a pretty simple thing. It's only a couple lines of code. I'm sure most of you know, but you get a prompt, you ask a question, then you give it to the LLM, it gives a response and some tools. You use all the tools, so like create files, edit files, and then you add the response to the log and do it over and over again until you quit talking to it. But really, this simple loop opens up a new world of development. Here is a quote from one of my colleagues, Navan, which sums it up quite well. Classic software tries to pin down inputs, outputs, and edge cases upfront. Agentic loops loosen that up. The system can now react to what it sees. The constraints move elsewhere. The user's intent, the tools on hand, and the quality of feedback. There's a link to his site if you're interested. So let's build an agent. The most important thing, the obvious thing is the builder agent, the one who will actually be doing the work. And truth be told, we found that the actual builder agent is quite simple. Implementation is very easy once you have a detailed specification, and the design is the actual hard part. So, to reiterate, the builder shouldn't be answering questions, you shouldn't mix human and AI code, you can fight its implementation decisions, but it will only slow you down. You should treat the agent loop like a person. Ask yourself, what can it see, what can it change, and how can it tell whether it succeeded? So those questions are answered through the tools that agent has to interact with the systems. So you should give it all kinds of things, everything that you use. So if you're building a compiler, give it the virtual machine and have it run programs against it. Give it logs, screenshots, responses. Previous failed attempts is quite important, like some flaky behavior over time, and recently changed files. Give it everything that you would have given to a coworker. Your job when managing an agent is to convert the data that you can see into tokens, into a representation the agent can act upon. So that was the builder agent. But how can you trust code that you haven't read? Well, you can't trust anyone. We are a cybersecurity company. What you need is a validator, which will make sure that the system can do everything you need from it. So what we do is we assume a little of, if it walks like a duck and talks like a duck, it is a duck philosophy. And basically, we expanded the concept of tests and we repurposed the word scenario to represent a user story. So, for example, a scenario is you are able to use the system to send over some files, then edit them, like them, view it. You put it in natural language and have the agents in a simulation perform all of the scenarios. So you have them assert that everything the user would be able to do is done correctly. For a validator to work, you should design your apps for agent use. The best way for now is to just make CLI applications that the agents can call, and you run simulations where the agents do all of the scenarios and pass or fail them. You are fighting against reward hacking, because the agent will do everything in its way to convince you the job is done without actually doing the job. And the scenarios deliver proof of working. So some examples. If you are building a web application and you want to support screen readers, you should spawn some agents using screen readers only and make sure that they too can perform all the actions. This way, any future features will also be validated against that. If you're developing a driver, you should give it the server, the client, your driver in the middle, and have it run queries and compare the results with and without it for parity. If you're building a compiler, give it the virtual machine and have it chip away at it. If you're porting something to a new language, you should give some clients of existing languages and make them use it when building a new one. The validation strategy is the most important thing in this loop. You should expect to spend about 10 times more tokens than on building to make sure that it all works. A pretty cool example of a validation strategy when you're building integrations is something that we have called the digital twin universe. So basically, it's MOX Plus. You have the agents build themselves an environment which is as close as possible to the real deal. You can gather wire data from official clients and have the agents ported to your own environment. You don't need to be 100% accurate, but you just have to be good enough for official clients to work with your copy of the service. And then you can customize the behavior, you can spin up some custom environments with users or whatever. You don't care about being throttled through the API, or you're not paying for the API. You have it all in memory. And mocks like that, I think, were always desirable, but they were unfeasible economically. You would have to spend months building this. Now you can have it run in the background. This is an example of a big change that the new software paradigms like bring. Things that were previously unfeasible, now you can have done in an afternoon. I have some screenshots of digital twins. So this is a copy of Google Drive. You could do everything with it. This is a copy of Slack, and we test against that, and then we release. If you're interested, there is some more info there. So the validator is the most important part, and it's what builds confidence in the product. The builder is not allowed to just say that it works. You have to have proof that the driver can connect, it can authenticate, it survives bad input, and that it matches the official behavior one-to-one. And this is hard proof. This is not just vibes. So that was the agents, and what happens when you put them together? The main loop is like so. You're building something, you have validation, which must be as close as possible to what you expect. And then you run the validation, you fail some tests, you learn from the mistakes, and you put the feedback back into the loop. And we found that the modern agents self-correct. And when you let it run for long enough, there is not much that we found they couldn't do. And the loop runs until all of the scenarios that you specified pass and stay passing. Our implementation of this idea is called an attractor. So attractor in physics is a point with which a changing system moves towards. So that's what we found. And attractor for cloud code. Attractor is to cloud code what cloud code was to basic LLMs. It orchestrates them. It spawns them over and over. And we have the agents prepare context for the next one. So it's kind of an agentic operating system because we can treat the agents as different programs and they call each other by inference LLM. The orchestrator is glue because it eliminates yourself as the pass messages between agents. You're not talking, you're not pasting anywhere. And what we are aiming for is a definition of done machine. So you give it what you want, and it abstracts away the implementation for you. The attractor consumes a prompt in the form of a dot file, which is a directed graph, which is kind of like cloud code consumes a skill to do such thing. So this is how it works. You plan out the workflow, what you want to do. Each edge in this flow has a prompt. The attractor walks the graph and does every step. And yeah, the agents prompt each other to get the work done. Yes. But a thing that has to be thought about is as the programs get bigger and bigger, all of this information doesn't fit in the context anymore. So we had to implement a memory solution, which we call pyramid summaries, because it looks a bit like a pyramid. Basically, there's too many things to remember exactly at once at every given time. So what we found was state-of-the-art greatly is adding a feature to your documentation, which is basically a more less info button. You put the documentation in a docs directory and have several different levels to it, where initially there is only a high-level overview of a concept, and if you, for this particular task, require knowing more about the system in details, you can dig down and get a bit more information. But of other systems, you only need the top level. And this allows Claude, when he sees such a directory, to walk it and manage its context in real time with perfectly zoomed in information for every part. So there's also an image. At the top you have little text, at the bottom you have the code if it needs to touch it. And yeah, the agent picks and chooses what it needs to know for the task. This parallels a little how an executive would approach making decisions, only digging down when they need to know the details. So there are a couple roles that you could give to your agents. In reality, you only have two roles. You have the builder and the validator, but you can give them some more hats for some more specialized tasks. So, for example, the researcher could help you figure out what you want. You could have some agents compile you a base of all available research in the internet up to this point, download it all, give you some runnable experiments, and yeah, it creates an inspirations folder that you can, at your own time, walk through and get an idea of what you're building. You could also have a specialist, as different providers do, different LLM providers do different things better. So Gemini is from Google, and it has really good access to Google APIs. It can search Google Maps, Google search, and if that's what you need, then the specialist is for you. Grok from Twitter, for example, has real-time data from tweets. which sometimes is useful, and Cloud and Codex are generally unstoppable at building. So you should ask different opinions, have them all think about your problem, and synthesize a solution. There's maybe like the maintainer you could have, which after you're done runs all the CI jobs and tests. It solves merge conflicts for you. Yeah, this role has its own place in the chain. Or you could have a lumberjack, which finds useless relay work in the middle and cuts it out. So you don't need this, for example. And in general, the roles grow and grow according to what you're building. You should put them in a bag and have them ready. Yeah, so what programming for us looks like now is a bit of like gearing up for a campaign in a game. You have some roles, you give them the appropriate tools, and usually the flow, you don't need to deviate from it too much, is research it, build it, validate it, judge the results, and document your learnings. And the important thing is updating your plan, because this feedback allows your system to grow to the right point. And you are programming with these rows and these arrows. You can combine them and mix and match them. So here are some ideas of which you could do, what you could be doing. The most basic flow is just building, validating, checking. But you could maybe have an evil builder, an adversary, which tries to break whatever the first one is doing. And only if it doesn't find any exploit, you go further. Or you could have two implementations which are developed side by side and with different agents, and only when they converge, you pass further. So these are like high-level ideas, but here are actually some production ready that we actually used. This .file developed our driver. This one did the other thing, and this helped me pass my exams. So it's quite simple, because truly you don't need too much. And we would like you to build your own attractor. The specification is open source. We don't share the code, but you are free to have an agent implement the attractor as described by the specification, and it will work. And every time you're building software, you should ask yourself, why am I doing this? Am I required to be doing this? And if not, ask attractor to expand itself to build the new feature. And if you're lucky enough to have remote access to your computer, you can do it right now. It grows with you. We have some stars on GitHub, and on our website we also have some community implementations which you can download and use right away. But it's really simple to get your own going. The specification is detailed. Okay, and what happens later when you turn the knob to 11? You put it on a server, you give it a Jira ticket, you give it the appropriate workflow, and have it get added, and later have it show you video proof of the system working. Some screenshots or some terminal output, or you could even maybe get some classifier which picks the best method automatically for you for the given problem. But we found it best to do these things yourself, to choose the topic and the approach. Right. So, some of our observations after working with this system is that the models have been good enough for all of this for a while now. We really are not waiting for bigger and better models. The Cloud Code agent style harness truly was the next milestone after base LLMs. It exploded the capabilities. You can even take some local simple models, build a nice harness around it, and have it work as an attractor. The harness is what takes unreliable components into a reliable system. Real programming still very much happens. You have to think about all the edge cases and everything that you need to have, but now it shifts to writing the ticket and picking the appropriate workflow instead of doing it manually. Yeah. But so some open problems are that the agents will not learn for you. You still have to educate yourself to make the best calls. It's best to be smarter than the agent. You can forget about being faster, but you should make the calls for him. Vision is really not there as of now. So for front-end work, you really need a brilliant human designer, because the agent really has no clue if the gradients look cool or not, or if the layout is approachable to humans. This goes back to the first point of agents being able to develop interfaces for other agents really well. They do it, but for humans, it looks a bit off still. And the big question of, is what you're building secure? Well, the agent doesn't know. You need a human expert to figure out all of the attack vectors before release and assure that they are handled in the ticket. What we found, and some takeaways for you to take home. The definition of done is key. You have to spend some time on it. The most important thing is the validation strategy. You have to you have to believe in the strategy. It has to be proving for you. You should be building applications to be runnable and testable by agents, and most importantly, invest in yourself. So stop looking at the code. Yes, I think that's true. You should just use the thing that you're building once it's done to verify. And this approach works because we aren't treating the code as the end product, only as a way to get to the app. So, for example, when I would be writing an email, I wouldn't get an LLM to do it, because that would be something that I would show other people. But we are not showing the code. We are just showing the application we're building. And all in all, at some different level, I believe that our job stays the same. Thank you.